Hello and welcome back to the Code Me Event channel. My name is Gabor Szabó. In this video, we are going to look at a Python module and we are going to add tests to this module. The module we are talking about is called Interval Timer. It's a relatively new thing on PyPy. I found it recently. What it does is allows you to create a loop and iterate with iterations where every time every iteration will start at a given interval. Okay, so let's say you would like to run something every 1 minute, and there's some function that you would like to run every 1 minute. Now, if the function ends after 10 seconds, then you would like to start the next iteration after 50 more seconds, so to have the full 1 second. And on the other hand, if the function takes more than 1 minute, 1 minute and a half, then the next iteration should start immediately because you are already past your scheduled time. So that's basically the module. It also has a flag indicating whether you missed your allocated time slot or not. And I have as I was testing the module, I had a strange feeling that maybe this indicator doesn't work the way I expected. Okay, so it works, and so I opened an issue and described the problem there. At the end, what I found that I think currently this indicator shows whether the new iteration, whether a specific iteration has started after it should be already finished. So there are these time slots for each iteration, and this indicator currently indicates whether the process has missed the not its expected starting time, but basically its expected end time. So it had the slot, but it started after the slot. And sort of my understanding would be that probably maybe, so that's my conclusion, is that probably there should be two indicators. One that indicates whether an iteration missed its starting time, and whether the other indicator may be showing whether it missed the end time, basically. So the whole time slot. Because if you miss the starting time, and and this is a short iteration, it might still be finishing inside its allocated time slot. So anyway, this is what I thought about the module, and let's see the test. So before actually the test, if you go into the source code, and you will find a link to the source code beneath the video on my website, and some explanation and the examples as well. So if you go into this source code, you will see a directory, a folder called examples, and inside there are a couple of examples on how to use the module. And I used these examples as the idea, a little bit of how to write the tests. So here is currently I can run the tests on my computer. I configured it with the Python path, telling it where to find the module itself, and running PyTest with -s. So we'll see some printouts that was included in the test. And let's see the test itself. So this is the test file. And in the test file, there are a couple of things that you will need to know. One of them is that I created a shorthand for false and true, F and T. So later on, as I describe the expected false and true for this missed flag, it will be easier for me to fit in a line. And there is also this variable called delta, because when you're testing something regarding the time, how long does it take, and when it starts again, you can't really expect exact values because you don't really know what else the computer does. So you'll have to give some way for some errors, and I use this variable to say that if there is a 0.01 second difference, shorter, faster, or slower, it's still okay for me. Okay, so the way I described the tests, after I fiddled quite a lot till I managed to find a way to describe well the test, and I think I found a way. So here you will have, and I take this the longest one for now to explain. Here there are basically four lines of describing a test case, and then we call a function called run test with three parameters, and that actually does the work. And understanding these three lines is the core of understanding how the test works. So the first row is just the expected timestamps of each iteration. And in this case, I will run the tests the iterations, sorry, not the tests, the iterations every 1 second. So the first iteration should start at 0, the second one after 1 second, the second iteration after 2 seconds, and so on, as related to the starting time of the test itself. That should be theoretically. Now, in this case, we will have, and this is the last row of all these four rows, the sleeps, which are a way to fake actual behavior of each iteration. So what we say that in this input, and this is the input of the test, that the first iteration takes 0.5 seconds in this case. The second iteration takes 1.2, so it's delayed. It's longer than the allocated time. Then 1.3, then 1.6. These are each iterations, and then again shorter iterations. So this is the input. And then what is the expected output? And these two lines are the expected output, basically. So the first iteration is expected to start at 0. Okay, so it's not just that it should start, but it's really expected to start immediately. That's okay. It will take, and it's marked as it's not missed its time slot. Then it takes 0.5 seconds. So the next iteration, so it ends, okay, it ends after 0.5 seconds because it started at 0 and it took 0.5 seconds. Because now we are at the second iteration, and the second iteration is expected really to start at 1. So we are also expecting in our test that it really starts at 1 and is marked as false. It's not missed its time slot. Then this iteration takes 1.2 seconds. So it started at 1, takes 1.2. So we are expecting that it will end at 2.2. Now, in reality, next iteration should already start at after 2 seconds, starting from the beginning of this whole iterations. But because the previous iteration started at 2.2, then there is no time to waste. There's no reason to wait anymore. So the next iteration is expected to start at 2.2. And here is the question, what this flag should mean. Right now, it means that the way it behaves right now, it's still false at this point, because we start before we should end. Okay, that's basically the meaning. This iteration takes 1.3 seconds. So adding them together starts at 2.2, takes 1.3, so it will end at 3.5 seconds. But the next iteration should start at 3. So because the previous one ended at 3.5, so there's no time again to waste, no time to wait. We start at 3.5, and again, it's still marked as false because it's still, according to the current way of behavior, it's still marked as not missed. Then this one will take 1.6 seconds. So this is just, the last row is just the test, the input. So that's how I decided what I would like to test. And what I'm testing here is what I call accumulated missing. So that's the name of the test, because we are leading up to a point where we start to mark the tests, the iterations to be missed, but not immediately. We'll do it in an accumulated way, as more and more iterations take longer than the expected 1 second or allocated 1 second. So in this iteration here, we started at 3.5. It took 1.6 seconds. Okay, so altogether it will end at 5.1, right? Adding the two numbers together, it will end at 5.1 second. The next iteration should start at 4, but it could only start after 5.1, so it actually is expected to start at 5.1. But at this point now, the flag is turned on to be true, okay? Because, and this is how I explained right now the behavior of this flag, because this time, this iteration already missed its allocated time slot. So it will start at 5.1, which is actually later than the next one should start. So it's later after it should already be finished. And that's sort of what the indication, the flag currently indicates. So this is why it's turned on to be true. The next time, so this iteration will take 0.5 seconds. That's just how I decided to give, that's the time to give for this iteration. And the reason I did this is because I wanted to wind down this delay, this being too late. So in order to see whether this flag turns back to false, that was part of the reason. So we made later and later, and then went back to be in the scheduled sort of time. So now this one starts at 5.1, takes 0.5, so we end. So this iteration ends at 5.6, which is, and the next one is expected to start at 5, or should start at 5, but because the previous one ended at 5.6, so we can only expect it to start at 5.6, and that's our expectation. And again, it's marked as false because now it already starts within the time slot, so between 5 and 6 seconds. And this one, so that's why it started 5. So now if this takes only 0.2 seconds, if we decided that this one will only takes 0.2 seconds, then it will end at 5.8 seconds, right? So it will start at 5.6 and takes 0.2, so it ends at 5.8 seconds. And the next iteration should start at 6. So now there is, it can wait at an additional, it should wait an additional 0.2 seconds, and next iteration should start at 6. And of course, be marked as false. And then this time it doesn't really matter, it's only there, so there will be an iteration or something to do there, but it doesn't really matter. So this was the longest test. There are a couple of other tests. So the first test was just testing short iterations, which are shorter than the allocated 1 second. So these are the two relevant ones. This is not really relevant. It's only there. The last sleep entry is only there, so there will be something, but the comparison only is done. The expected output are not relevant anymore. So it won't generate an expected output. So that was the first test. The second test I created was when we went to immediately to some missing values. So here it was, okay, the first iteration was still within time, and the second was already way too long, and therefore the third iteration was marked as having missed its allocated time slot. Okay, and then it's winding down again. So this was a shorter version of that, or a version in which we jump immediately into missed mode, and here we are accumulating the delays, and that's how we got to this missed mode. Okay, so these are the tests. Actually, it could have been written using the parameterization of PyTest, but I felt that the way it's laid out is clearer. And then the run test itself is not, it's actually the less interesting part. It takes these three arrays, these three lists basically, and calls here and some function called run, which maybe I split it up into a little bit too many functions, but that's how I created it. And here is when we call the iterations, we use the actual interval timer, and then we store the timestamps. So when each iteration starts and these interval objects that the function that the iteration basically returns, and we break out from this loop if we ended these values from the sleeps list. And then there is some function just making sure that the indexes in this in the received lists are correct. Not really interesting. And then here is the code that checks whether the expected time is more or less, so with an error of delta, minus or plus, within that is equal to the expected starting time. Okay, so there is the starts, the list of starts is the list that we are expecting. Okay, so these are the starts that we saw here, and this is the expected start time, and this is the real start time, okay, for each iteration. And then we are checking whether the real start time is close to the expected start time in both directions. And then here we are checking this missed flag. And that's it, basically. So I'm going to send this as a pull request, and we'll see if it's going to be accepted. And once the test is accepted, then we can also add configure continuous integration, configure GitHub the continuous integration of GitHub, and have a test to run all the time. So thank you for watching. And if you like this video, then please also mark it as like and subscribe to the channel. And that's it. See you next time.